Okay, so continuing from yesterday, finishing off the introduction into Python programming notebooks, and then after that, we're gonna get into some data cleaning notebooks on Anaconda Cloud, and we'll go over this notebook that is made for today's class. So let me actually change it to full screen. Yes. Okay. Is this readable, big enough? Everybody can see this text, hopefully. But yeah, yesterday we went through strings, numbers, booleans, collections, and then some imports. And today we're going to go over functions and rules, which are pretty much called conditions in my opinion, and then some different kinds of functions and loops, and then errors, and then finish up with classes, and then we're going to get into today's scheduled content. But yeah, we touched a little bit on the functions to make sure that everybody understood what a function is. But basically, you make a block of code that can be like reused, and it can take arguments. And in Python, it is you're gonna use def, so def, and then you're gonna put the function name and then arguments that you need. It can be empty, and then so the function name and then the colon, and that's how you're going to write a function in your Python code and then call them. And then there's the built-in functions in whether they're already built in Python or then there's like additional libraries that have different functions. So like round is a function that helps us round integers or numbers, decimals. And then from math is a Python library. We can import a function called sqrt, which is a square root, instead of doing the math ourselves. And then we can do a list and zip. So we're putting function in here and then making a list out of it. And functions that can either be used by just passing it like this. And if there is a return value, something to be output, it will output it. Some of them always don't have it. So you'll have to like reassign it to a variable in order to do that. But here we can see like I think we talked about when we were going over strings, there's the strip and then lower. So basically the string method, this one strips the extra spaces and then this one puts it all lowercase. And here's how we create a function. So we have the def and the function name. This is where you're going to put the arguments. So s is an argument that's going to be passed into the function. Then we have the colon. And something I think we didn't cover about Python yet. So if you've ever seen any other programming languages, there's, in Java, they have brackets, just quick lines, and that's how you kind of set where the text, like how it's going to be read. Python, it uses tabs or spaces. So the indentation tells you where it belongs in the code. So, and this one's going to do it like automatically whenever, see how it automatically indents it. It wants you to put it inside of this block of code. And that's something to remember about Python, is that you need to have your indentations properly, otherwise it's not going to work. So this one basically, it does the same, like lower, and then we can just do it this way, same thing. However, this one, the reason, even though we're assigning here, like art equals lower of this one actually doesn't return any value. So that's why when we're trying to assign the function or like the output of this function to art, it's going to give us none. In order to do that, we'll go over here. So we need a return value. So printing art is none, type is none. So in order to actually be able to assign the proper value, so this value to art, we'll have to add a return value to the lower. So here, this one just prints it, and then we could do return s.lower. And then now, when we do it, let me use the same thing here. Now we see that it's actually assigned to the variable. This one doesn't work also because when there isn't a, so how this was previously, this one's going to give us an error. Because again, there's no, it says like non-type object because we're not returning anything. So it's only out, like it's only printing it out, but it's not actually outputting the object or the variable. So when we call upper on the output of this, it's going to give us an error because it's not there. And yeah, here's even simpler way to do it. You just do return. And there's different ways to kind of do the return statement. So like you can do a variable and do whatever modifications you want to do it and then return that variable. But a lot of times you can just do combine it on the return statement. So here we can see now it put all in lowercase and then it put all in uppercase. And here we can see that that's all lowercase. Any questions? So a little bit about the function anatomy, talked about it a little bit before. So def, name, arguments, and then the return statement. So here, a sentence, we want to replace George with Art Vandelay. So here we can see that George was replaced with this. Then here's, we're creating a new function, which is doing, so first is replacing George with Art Vandelay, then Jerry with Cal Warnson, Kramer with A.G. Pennypacker, and then returning the changed string. So we can say Art Vandelay, Cal Warnson, and H.D. Pennypacker's business. And you can have, so you can either have 0 arguments, 1 argument. So this one, we only have 1 argument in here. Which, yeah, we saw here, we saw earlier. Nothing new here. And then we can also have 0 arguments. So if you don't want to pass anything in and you just want it to return something, you don't have to pass anything in. And it could be also like, you don't need to have a return statement here. We could do also print 4, and it'll give you the same. Here's an import random, and then this one, it picks randomly something from our string. So random is, I think, is used a lot in different data science projects where you want, if you're making like simple data, or you just want to pick something randomly from your data to calculate something. Random is a very popular library for that purpose. And then we can also have multiple arguments. So here we have 3 different arguments passed into the MATLAB. So here you can either call it this way. So argument 1, argument 2, argument 3, or you can actually put like, if you're not going to write the name of the argument in here, then they have to be in the order that they are in the function. So name, color, country, but you can also pass them in if you kind of assign it here. So we say color is this, name is Max, country is Canada, and they don't have to be in order. So here, if you do it this way, they're not going to be in the right order. Then also sometimes you might deal with different functions that you want to have a default value for. So like it doesn't have to be passed in there and it can be overwritten, but having a default, so it might be none, empty, 0. So here, this one's putting a default argument length equals 20. But then you can, so if you don't pass it in, it's going to give you 20 characters. And then you can override it with 100. Any questions? If I'm going too fast, let me know. Then we have, if you're not sure what a function does, you can just do help and then put in the function name. And it's going to tell you what it's going to do. So, so built-in function round, and this is the module that it belongs to. It's going to show you what the arguments are. We can say this one's like the default value, so n digits, it's going to be none by default. It tells you what it does. So round a number to a given precision, it is in what digits. And this is how you, when you're creating your custom functions, this is how you're going to do it. So you do the 3 double quotes, then your description of it, what the arguments are, and then what the return is, what the return type is going to be. So here's our custom, then we're going to do help on DNA, and it's going to print out what we wrote in here. This is like good practice to do when you're building your programs or when you're programming Python. Not everybody does it, but yeah, definitely very good practice to do it because it's going to help you and it's going to help other people who are looking at your code to figure out what it's supposed to be doing, especially if it's not super clear. And if you're not using like descriptive function names, this is almost like necessary, because if I were to just call this like XYZ, then no one will know what it's supposed to do. So kind of like you want to use very good, proper descriptive variable names, we also want to do that with functions. Then we have something called lambda functions. Lambda functions are nice. It shortens your code a lot. It might be a little harder to interpret it, but like once you get more familiar with the syntax, it's gonna get easier to read them. But basically what we do is you can put like a block, your lambda function inside a function or a variable, and then it will do it for all of it. So, so like lambda length, we want to join all of these random choices together. So DNA and then lambda length. So that's just printing out what the function is. And I'll show more examples of this later on. I feel like this is not the greatest example here. But yeah, it is a very useful way to make your code look simpler and cleaner. But yeah, we'll touch on that more later. Filters. So here's another. So we're passing in a lambda in here. So basically, for this list, so our list of songs, we want to filter them based on this lambda. So the lambda is saying basically like, oh, for every x, if the x ends with .mp3, then like that's the filter. So only choose songs, or yeah, only choose songs that end in .mp3. So here, filter, it goes right here. So filter the songs based on this lambda, and then give us a list out of it. So that's like, instead of writing a loop, which we'll get into loops in a second, but like instead of writing a block of code, be like, hey, loop through every single one of these variables or these elements in the list, and then only include them if they end in .mp3, we can just use a lambda like this, and it's going to shorten and make your code a whole lot cleaner. Any questions? Then we have map, which basically helps map. So let's see what this one's doing. So map in the songs, the lambda is a string of my song underscore get the first. So here we're splitting the song. So this is the first song, for example. So split that with period, get the first element after it's been split. So when you're splitting things, it's actually going to put it in a list or an array. So we want to get the first element of that. So this, in this case, it will be 1. And it's not going to include whatever the split value was. Very similar, like in Excel, if you've ever done like data to columns, like it's just going to get rid of whatever the character is. And then, so my song underscore, it's going to get number 1 here, and then put .flac. And what it's going to do is like, it's going to map from each song, it's going to map the split. So the first one, and this is what we get. So my song underscore 1 .flac, my song underscore 2 .flac, my song underscore 3 .flac. So it kind of like the mapping we needed to be able to do it for like multiple of them to be able to properly map the with the lambda. Then there is reduce, which basically so again, we have the lambda in there. So lambda result and value give us the sum of them. So what this is doing here is summing all of these together. So this would be same thing if we were to do sum of this, I think. Yeah, so these two are identical. So I feel like this is not the greatest example. So I also added here, that's not the only thing you can do. We can also do like, oh, lambda A and B, if A is greater than B. So A, if A is greater than B, else B. So this finds the greatest number in this list. So basically it looks at each one of like each element together and compares it to the next one. And that's how it's gonna figure out which one it should return. So yeah, here, sum, this is the same thing. And this is the same thing as max of this. Gives you the same thing. So it's just a different way to, if you are doing something more complicated, we want to use reduce. Then there is the star args and then star k quarks. I don't actually know how to pronounce this, but I'm assuming that's how you would say it. I don't think I've ever heard anyone say it out loud. But yeah, so we have different kinds of arguments that can be passed into a function. So like we have the regular arguments that we were looking at previously, and then we have the star args that allows you to pass any number of position arguments for the function. And then they're accessed within the function as a tuple. So is a great way to, or you'd want to use this when you're not sure how many arguments might be passed in there. So like here, like we do a function, def print all. We don't know how many functions we want to put in there. So this one, it will take in all of these, or we can only pass in these ones. So it's flexible that way. So that's when you would want to use the star args. Then we have the star quarks, KW args. So keyword args. That's what it stands for. Yeah. So it allows you to pass any number of keyword arguments specified by name, access it within function as a dictionary, and then again, useful when you want to handle named arguments in your function, but you don't know beforehand what they will be called. So here we're passing in these 3 arguments in here, and we're naming them like different things. So previously we saw, I think there was let's see. So this example, so color, name, country. So if we don't know what we want to call them yet, we can use the keyword args. So here, first equals hello, second equals world, third equals example. So we're going to pass in here, and then it's just going to print the key and the value. So it's going to treat it as a dictionary, key and the value. And then both can be used. And then we can also use regular arguments. You can use all together. So here first, we're passing in these 3 arguments. So these get printed out right here. And then here's our keyword args, and they're going to get printed out afterwards. Any questions? If you're following along, looking at this notebook, there's a couple of things that I've like added in there. So that's why you might not see them in yours, but I can also share this copy if anyone wants it. Okay. No questions? Okay, moving on to, and then rules. So rules, rules. So conditions, if else, condition. So if you're familiar with like programming at all, you've possibly seen like, oh, if else, and kind of like a joke about these trained machine learning models and whatnot, like that they're just like big if else statements. So there's like a bunch of if this, if else, whatnot. So it's really not that like rocket science. So yeah, we have, so month equals September. If month equals August, print play volleyball. So this is our rule or condition, our if statement right here. So nothing got printed because our month is equal to September. Then here, another one, so month. This one we looked at in the Boolean. So does month equal August? No. So if we were to change this one to August, we would get it printed out, and then this won't be true. It's a very simple if statement. We can do multiple if statements. So month is June. So the only thing that gets printed out here is play volleyball. And I think after this, we'll go to the else. So this is pretty much like the joke about like the machine learning or AI or whatever. It's like just a bunch of if statements together, and that's gonna like determine what it should do. Which some are more complex than that, but that's kind of what people say. There's months. So this one, so we have the months here. So Jan, Feb, March, so on. And then we want to create a dictionary of them. Passing in months and then the range. So this zip is going to help you map it out. So from range 1 to here again, like if you guys remember, index always starts at 0. So we don't want January to be 0 here. So that's why we're doing 12 plus 1 here. So it goes from like 1 to 13, but that's actually only 12 things. But yeah, so the zip, it maps each one of the months to whatever the number should be here. We get our dictionary back here. And then here is how we can check, like, okay, so a current month is June. If the current month, so for months, this is our months here. And then we're looking, so dictionaries, we covered them previously. So we're passing in June basically here. So we want to get June. It's going to return value 6. So basically this is going to resolve to 6. So if 6 is in this list of these numbers, we would print snowboard. It's not. And then here, if current month is in this list, print volleyball. So 6 is in here. And that's how you can check if a value exists in an array or list, just with the in word. Then we have else statements. So if else, so again, current month is Jan. So this is going to result to 1. If it's in here, then we're going to print volleyball. And if it's not, this is going to be like the default. Sit on couch and watch Netflix. Perfect. No volleyball. If you want to include multiple conditions, so instead of just doing like if or like if else, we can do elif. I think in Java it's just like else if they actually spell it out. Python it's elif. So again, same thing here. So month number. So if month number is in here, so April is 4, print snowboard. Then else. So if this is not true, we're going to move on over here and then check if the month number is greater than 5 and it's less than 9, then it's going to do print volleyball. And if that's still not true, we're going to move on over here. However, if this one were to be true, so this one still prints out this one. So let's see, we'll do December. So this one's going to print out snowboard. So basically what's happening with like if, elif, else, only one of them is going to get executed. If you have the if, like you have multiple ifs, which here, so this one, it's going to execute every single one. Like if it's going to check every single one of them. Like if all of these, if it was a different, like we could put like if true. Now it's going to print this one and print this one. So that one to be careful with, like what is the behavior that you're looking to get with your program is like, do you want every single one of the if statements that you are, or is it like if else? So only one of them gets executed. Let's see, 3 month number of months. So here we're defining a new function activity. We're passing in month. Then we have a default value of summer equals play volleyball, winter equals go snowboarding. We're going to get our month number for months. Which this one? Yeah, it is. Yeah, month number. So we're going to get the month from there. And if it's in here, we're going to return winter, which this one's going to return go snowboarding. And then if it's between 5 and 9, it's going to return summer, and else it's going to return sit on couch and watch Netflix. So here we'll pass in July, summer, go sailing, winter, go shoeing. And we're going to get print out go sailing because July is number 7. So it's this one got executed, but it didn't. We overrode the default value here. So if we were to just do this and just put July, now you're going to get play volleyball because that's the default summer activity here. Any questions? FizzBuzz, I think this was the first thing that I ever learned to do when I first started coding, was like, oh, figure out how you can like write a function, how to get the FizzBuzz printed out. So players generally sit in a circle. The player designated to go first says the number 1, and the players then count upwards in turn. However, any number divisible by tree is replaced by word fizz, and any number divisible by 5 by the word buzz. Numbers divisible by 15 become fizzbuzz. Player who hesitates to make blah, blah, blah. That doesn't matter. So number 5, this one's going to give us buzz. And here what's important to note is because the last condition is numbers divisible by 15. That these need to be in the correct order, because obviously like 15 is also divisible by 3 and 5. So that needs to be the last thing in the function. And here we're saying this is the modulo. So we want to get the remainder of the number. So what is the remainder when we divide the number by 3? We want it to be 0, which means it's divisible by 3. And that's what these ones mean. And then, yeah, so this one's going to do buzz, fizz. And then if it doesn't fit any one of these conditions, here we're just going to do a return number. And you might notice like earlier when I said, oh, if you just do like if, it's going to like check every single one of them. But if you put a return statement inside the condition, it's not going to continue. That's where it's going to stop. It's going to like, okay, we got a return statement, we're going to go back. But this one could also be like, this could be done differently, where like we did output equals the output equals number, and then if number equals this, we're going to override output equals fizz. And then we could like do elif output, oops, and type today equals buzz. And then last one is this, and then return output, and then still going to work. And this one could elif, yeah. And this one could actually just be else. Well, then we would need to return. But yeah, you can also do it this way. So there's a lot of like, oftentimes you can write things in many different ways. This is number. So here we can see if they're in a different order. What do we get here? Let's see. Number 10 like this bus 15, 4, 4. Number 3, number 5. Right. Then if we did. Oh, wait, hold on. Did I say that the wrong way? I might have. No, I didn't. It's still the same way. Anyways, yeah. So, yeah. Any questions? But yeah, this is how we do our rules, conditions, if-else statements. And then you guys can do the homework yourself. Any questions? Okay, moving on to repeats or loops, terribles. So basically when we want to like do something multiple times over time to a list of things, multiple arguments, we don't want to type it for everything. I think like another like programming joke is like, oh, like you want to write a function that that returns whether or not a number is even or odd, and then like the engineer like writes like, oh, if it equals 1, return odd. If it equals 2, return even. If it equals 3, return odd, and so on. So we obviously don't want to do that. We want to make sure that our program can take different kinds of arguments. It can be dynamic. We don't want static, stuff like that. So that's where loops come in, functions, different kind of repeats. So here we have a function mp3 to flag, which is going to return my song. And then we saw this one earlier. We actually saw this example earlier too, where it's mapping the, so all of these songs, it's mapping then with this function. And then it returns us a list of converting from mp3 to .flag. Here's our loop, and we can also use it. So for each song, print out the conversion. So flag song equals taking the function, passing in the song, printing out what the return is. And this one could also be like, we can just print this out like this as well. So you don't actually have to assign it into a variable first. So this is what you get. People keep popping in, popping out. Then something that we can do, so iterables. So when we do for number in a list, print the number. And this one you can call anything. Like you can do n. Oh, oops, sorry. Yeah, sorry. This one needs to be n. This one needs to be n. Yeah. So as long you can name it whatever. So basically what we're saying, like, oh, like this element, for each element in this list, do this. And in like Java, this is called for each, and you would have to write it out. And I think Ruby is the same thing. Python just simplifies it for, so for number in this list, print that number. A letter in this sentence. So this one, it takes each one of the characters in the string here. So depending on what it is, that's how it's going to determine what this is. And I think we'll see a example of like when you're dealing with the dictionary, how it's going to do that. So here, let's see, we have a turbo one map. Do we do anything with this? I don't think so. But yeah, so for I in range, and this is what we see a lot, is like, especially like for loops, you will see a lot like, oh, for I in range, or like for I in numbers. And then if you have another nested loop, so which means you have a for loop inside a for loop, you usually say for I, and then you say for J. Those are like very common. And then the next one somehow is for K. I don't know how that happened, but somebody decided that. So here is from range 1, again, how we saw. So index starts at 0, but we want to print from 1 to 5. So we had to add an extra one here. And we could do 6, and you get the same thing. But since we're not starting at 0. And if we were to do 6 here, it would now it does from 0. So the default argument there is 0. So if you don't want to start from 0, you'll have to put the starting index. For loops. So I feel like these are also, I don't know what this is called, to loop, honestly. Same thing. For loops. So for song in songs, doing the same thing. And then we're going to append them to this list of converted. We get our list of converted. And then here, I think this is the same thing. Yeah. So here we see like lambda and then the mapping. So instead of doing a loop, that's what I was saying earlier, like you don't have to do the whole loop to do it. So we want to get a list of this mapping using lambda condition here. So for each song, split the song, flag, the same thing. And then this is the list of things that we want to map. So this one, like, it's gonna make your code shorter, but is this easier to read than what's happening here? That's kind of like where you have to figure out, because you want your code to be readable. You want to make sure that other people can understand it, but you also want it to be like clean. So it's a fine line between making it efficient looking, you know, and then also making it efficient. Here's our fizz again. And so this one takes so fizz numbers for number in range 1 to 101. So 100 numbers. Append each fizz number. And then this one's basically printing all the, well, we get fizz or buzz or fizz buzz if it's divisible by 3, 5, or 15. And the rest of them is just printing out the number, because that's what it is, the default value here. And here's a shorter way to do it. Also in notebooks, if you ever like, you know, this one printed out this whole block of code and you just like don't want to look at it. So you can like restart the kernel, which you can do from here, like restart kernel and clear all outputs of cells. But like, let's just say you just didn't want this output anymore. You can just like comment it out and then now it's no longer there. Enumerate. So in order to like loop through things here, so enumerate is basically, it's gonna give us, so our index and then a day here. So our list, and then, so for I, for index and day in enumerate DAO, print out the index to the day. And that's what you can do. And then there's some like data types that you have to use this on. Lists, you can just do like the for I in that. And it depends, like sometimes you need the index too, depending on what you're doing with your function. Yeah, I'll leave that challenge to you guys. Then we have while loops, different type of loop. Basically, what a while loop does is, as long as this condition is true, it's going to keep executing this. So we have a target 100,000 visitors is empty. So as long as the sum of visitors is less than 100,000, we're going to keep executing this. And so each time this runs, so day equals random range from between 300 and 10,000 visitors append a day. So as long as the values inside the visitors is less than 100,000, it's going to keep continuing this. So this one, it randomly picked 18 different numbers that equal to over 110,000. And we can, so here we see, so visitors, these are all the numbers that got generated. And then we can also do, let's see what the sum ended up being. So this one ended up 107,058. So that is greater than 100,000, and that's when it stopped. Then we can, that's like one thing to be very careful with, which IDEs, almost all of them, you have a way to stop the program, but you want to be careful of like infinite loops. So if we just had while true and there was nothing that was going to like, if we didn't have this break statement or return statement or something, this one will keep running forever. unless you like kill the process, stop the program. So that's something to be very mindful of. You don't want to have infinite loops because it's going to break things. So here, while true, response equals input, do you like vegetables? If the response is either yes or Y, then it's going to print same and then break it. So basically, this is going to keep running until one of these responses are inputted. So input means like it's asking the user an input. So this was just going to keep running until. So here, if we just did no, whatever, it's just going to keep running until we do Y. It's going to do the same. And this one also we can do yes, because it's going to convert to lowercase here. Let's see. Here, I think the same example from before. List different ways to append these. So this function returns these things, and then this one maps them. But then we can also do it like the for loop in here. So for this function, pass an x for each x in songs. And again, here, like you could rename this to be song. You can call it anything, and it would be better practice to call it a song instead of just x, because x doesn't really tell, but it's normal to do x or how we saw for I. It's not that common. And here, same thing, for x in songs, these songs append and then print. So just different ways to achieve this. Emojis. So this one, dictionary, get the angel face. I actually don't know. Maybe it is good. I don't know what it's actually called. But then if we try to get good, there's no good because we don't have a key named good in here because these are the keys. That's a value in there. And then here, what we're doing, I think this one flips them. Yeah. So emojis do to value key for key value in emojis. So basically, we're going to look at the key value pair in emojis items. So items gets you like these pairs, and then we have key and then value. So it's going to get both of them. And this can also be called, you often see K and then V. But what we're doing is we're creating a new dictionary here that is reversing the value and the key. So the value becomes the key here. So from emojis, we can get it this way, and emojis too, we can get it this way. Any questions? Recursion. One of my least favorite things. I think one of the first classes that I ever took in programming, recursion was like so difficult for me to grasp. And I don't know why, because it really doesn't seem that crazy anymore. But for some reason, it just was. Where's my, here we go. I included this at the end here. So this is how you often recursion is shown. Yeah, this one, let's see. What is that with? Okay. So with these like little dolls, so that's what recursion basically is. Like you have a doll and then there's another doll in there, another doll, and it just like continues forever. Or then like it's a box and a box and another box and another box. So that's kind of like the real world example of recursion. So here, what is happening? So recursion means like you are calling that function inside the function. So our function name is countdown. We pass in n here, and then we're calling countdown inside countdown. That hopefully makes sense. But what is happening here is like, oh, if n is greater than 0, we're going to print n, and then we're going to call countdown again. But this time we're going to do n minus 1. So we started with 5, so here we see 10. The next time we're going to call countdown with 9. So here's this, and then countdown. So it's going to print 10, 9, 8, 7, 6, 5, or whatever. And then once we call countdown with 1, so 1, it's going to come in here, and then next time we're going to call countdown with 0. So n is no longer greater than 0, it's equal to 0. So we're going to print it, and that's when it ends. We're no longer calling the recursive function here. Any questions on that? I feel like it's like not hard to understand, but then once you have to apply it, it wasn't clear to me when I first learned about recursion. But yeah. So, and then here's, this is, different way. So instead of using an if statement, we're using while. So while n is greater than 0, print n, and then every single time we are subtracting 1 from here. And then once the while loop is done, it's going to print this, and then so recursion, you can do it this way, or you can do it with, like, this is not recursion anymore, but it gives you the same output with the file loop. So again, a couple ways to achieve the same thing. This one, I don't know how much it's going to be used, but a fun library that there is TQDM. So basically what this does, it gives us this little download thing, which you will see if you're like installing external libraries, you might see this, or if you're installing something, whatever. But this is just a cool way to, if your function is taking like a really long time, you can use this to do it. But I don't know if you guys are going to be using this anytime soon. Just something cool. Any questions on recursion, on loops? Everybody good? All right, we'll get through these, and then we will take a break. Errors, this one will be a quick one, yeah. So common errors, we have our list index out of range. We saw that a little bit earlier in the last class. So we have our colors, and we have 5 things in here. So when we're trying to access colors 1000, that element obviously doesn't exist. We only have 5, 0, 1, 2, 3, 4. So 4 is the last index that we have in here. So index out of range. I think that's like one of the most common ones that you will see in the very beginning, because if you haven't grasped the whole thing with like everything starts from 0, and then especially in Java, I think, because when you go the whole for range, for loop, that one, it needs to be like -1 often, because if we're taking the length of an array, and it's going to be 5, but there's actually only 4 indexes. So you'll probably see this a lot. I definitely did back in the day, and maybe still sometimes. Then we have, index error, then float, could not convert, value error, because float, we're only expecting, so a decimal, we're expecting there only to be one period. Then we have key error. So if we don't have the key that in the dictionary, we will get key error. And this can be avoided by doing, so vocab.get, and then doesn't exist. So that this way you're not going to get the error. So better practice. true and 0 or name these ones. I don't know if that one's supposed to give an error, but technically these are different data types. Name is like not a Boolean, and 0 can technically be considered that. Function. This is another thing that I think is very common, is trying to combine two different types of variables. So one here is an integer, and then one here is a string, since it's in double quotes. So we obviously can't plus them together. So unsupported operand types, type error. So int and string cannot be combined. But we could cast this in, I think, is it int or uppercase? No, is it lowercase? Yeah. So we casted this, then that would work. And we no longer would get a error. So great way to deal with errors is to use something called try catch, try except. In Java it's try catch. In Python it's try except, pass, float, cannot convert. So basically what is happening is like, hey, try to do this block of code, and if you're gonna get an error, handle it in this way. So this one's gonna print whoopsies because we're not able to do this. There's different things you can do here. You can like write a separate function to handle a specific type of error. So here we're so accept value error. But I think if this was an error, it would that's not error. I think exception E as error as in E, something like that. No, exception. Is that what it is? I'm trying to remember. As E, yeah. So this one's like gets any type of error exception that you're gonna get, it's gonna catch it. And then we can also print it. So print, so E, so exception as E, print E. And then it's gonna tell you, could not convert string to float. Oopsies. Any questions on that? So here, price. So we have our function discount passing in price, and then we have a default value 0.20. So try price equals price, replace $sign with nothing, and then replace comma with nothing. Then attempt to turn it into a decimal float. And here, so what's happening here is, so we're passing the 10,098. And the reason this worked, because like we can handle, float can handle a decimal. So it got passed in here, replace the $sign, and then replace the comma here. But if we just had, if we didn't have this, oops, here, it would. So it's handling this value error here, and it just says return none. Then another thing, race basically means like, if it's not a built-in error, like it's not something that Python is gonna think is an error, but you want your program to tell like, hey, in case of this thing happens, like throw in an error. So here, if by is greater than 1, raise value error. This obviously is not an error if like Python's not gonna think that an error, but your program has decided that this is going to be an error because by this one is supposed to be a percentage. Raise a value error. Can't discount more than 100%. So here we're raising value error. And this is how you read these ones. It's gonna be a little bit of a skill to like get really good at debugging. These days, you can usually just copy paste this into ChatGPT and it's gonna tell you what it means. But basically what's happening here is, okay, this is where the function ended. This is where the error was raised. And this was the thing that was previously called. And it tells you like, what line it is and the cell number. And if this was just like in Visual Studio Code, so you're not in a notebook, they'll just tell you like the line number. But yeah, you're going to be following it from, I think it's easier to go from up or from down to up, because you'll know like where the problem is and then how did we get there. So this is where the error ended, and this was the thing that was called before. So you get your like little call stack, your traceback. Any questions on that? And then you can also do warnings instead of errors. So warnings, use method 2 instead of this. Just different ways to like warn the users that like, hey, this is not necessarily an error. It's not gonna stop the program from executing, but yeah, pandas will give you a lot of warnings. And we have default ignore an error. Warnings warn. So here's simplified error. That gave nothing. This one, you can do your custom warning. But ignore warn, warnings warn. Yeah. And then if you hear growling, that's my dog in the background because he's crazy. So yeah, feature warning, warnings, catch warnings, with warnings, catch warnings, but ignore, letter, random letter. So this one's basically saying like, oh, don't give us the warnings. You can like turn them off if you don't want to see them. Any questions? All right, we'll do, actually, maybe we'll take a, let's take a break right now and then we'll finish with the classes and then we'll get into the notebook. So we'll do 7-minute break. So till 15 after? Is it 8? Yeah, 8:15 p.m. Central Time? No, 7:15, right? Yeah, no. Hold on. Yeah, 7:15. Get confused with these things. That's correct, right? Because it's 8. It'll be 8:15 here. So 7:15 for you guys. Okay. So we'll be back by 7:15. Okay. Can everybody hear me? Make sure. Yeah, I think everyone can hear me. Yes. If not, yell at me. Well, you wouldn't be able to know. Yes, perfect. Okay. Okay. So classes. Talked a little bit about object-oriented programming. So Java, Python, examples that use OOP. So basically what a class is in Python, it's like a blueprint for creating objects. And what an object is an object that has attributes, methods. So data structure consistent of data fields, methods together, their interactions. So when you want to create a specific type, like dictionary is an object, and you create instances of dictionary. And here, let me zoom in on this one. So classes, user-defined data types that act as a blueprint for individual objects, attributes, and methods, then covered objects, and then methods or functions. And then kind of when we did like the dir, and then you pass in something, it's going to tell you like all the possible methods, functions that are for that object. And then there's attributes. The attributes would be attributes or properties. There's like a couple of different words for these. So like think about class is human, then object would be Emily, will be a type of human, and then properties, they have their own email, like emily@gmail.com, their own address, and then they have methods like sending mail. So that's kind of like the gist of classes and object-oriented programming. So like classic example, dog, animal. So class dog, and then dog can sit, dog can roll over. They have a name, they have a breed, and then you can, this is how you make an instance of a dog. I think this will be better to say like, oh, like my dog. So this is going to, oops, run this first. So my dog is a type of dog. Her name is Fido, and they're a German Shepherd. And then my dog sit, Fido is now sitting. So here we see, so this init function over here is what initializes when we're creating an instance of the dog. And you need to pass in name and the breed, and then they get set for this specific dog. These are going to be the attributes. And then when it sits, it's going to grab the name, now sitting. Same thing, I'm going to do a rollover. And then, so this one is my dog, type is dog. So if you guys remember when we did, if we were to do like d equals dictionary, and then we did type d, it's going to tell you that it's a dictionary. So same thing here. It's just a different kind of, it's a dog. Questions on that? Here's a little more real world example versus this one definitely like could be, I don't know, you're developing a vet app or something. It could totally be a thing. A lot of times you say like a vehicle, so type of vehicle. So you can have a car, motorcycle, and then they have different attributes depending on what kind of vehicle it is. Or again, it would be animal, and then dog or cat. So real world, so create a dictionary that can do two-way lookup. So our dictionary, we have from Chinese to English, and then we want to also be able to get it from English to Chinese. So we're just creating a regular dictionary, setting values, get it. So here we're creating a class called bydict. So we can look both ways. We're going to initialize it with data. So key dictionary and then value dictionary. So this is going to be the full dictionary and the value. It's going to set value equals k for each. So value equals key for each key and value in data items. So, and this is how we're creating. So vocab is going to be an instance of bydict, and we're passing in. This is the dictionary that we're passing in, and then from our key dict, we can get the ni hao. So, and then from the value dict, we can get hello. But we cannot set it this way because we initialized it, but there's actually no, like you can't just set it unless you've defined a method to set it. So like in Java, you have getters and setters. You have basically the same thing in Python. They're just like not as obvious, I feel like. Because if you're like developing in Java and Visual Studio or IntelliJ, it can just like, it'll just kind of, they have like shortcuts to like just do it for you. It'll write out all the getters and setters. So like this is how you can get this attribute, this is how you can set this attribute. But we can't do this because we initialize it this way. So what we want to do instead. So again, we have our class bydict. If it's an instance of dictionary, so if data is an instance of dictionary, type dictionary, then we'll set the kdict to data. Otherwise, data must be a dictionary. So we have our error here. And this one could also be try, except. And then property, so vdict. So this is the k, so getting things by the key versus getting things by the value. And I'll touch on why we have an underscore here later. And the same thing, we'll talk about these ones in a little bit. So the value, again, here we're flipping them. So from the key dictionary, we're flipping. So we want to get it by value instead of the key. And then now we can do get. So we have a get method here, get key, and then we're going to get it from the key dictionary. So did I run this one yet? Yeah. Vocab, bydict. So again, we're doing the same thing, creating a new instance. We're going to get ni hao. So that's our method here. And this one's like already in, we saw before, like in dictionaries, we have the get method in there. And we'll talk about that later on, how you can inherit from parent classes and stuff. And now this one doesn't work anymore, I think. So bydict object is not subscribable. So we no longer can do this because we have the get method here. And this is how you can get the value dictionary. So from hello to ni hao. Okay, so dunder methods. So these are when we were looking. So dir, dict. We get all of these different methods. These ones that have the double underscore at the beginning and at the end, these are called dunder methods. And it comes from the double underscore. So dunder methods are methods that allow instances of a class to interact with the built-in functions and operators of the language. Comes from the double underscore because the names of dunder methods start and end with two underscores, for example, underscore, underscore, string, underscore, underscore, or add. Typically, they're not invoked directly by the programmer. And that's why it kind of like is like magic, because like the init, this is a dunder method, but how that actually got called was when we created a new bydict. So we just created this and this thing got called. So it's like magic. Not really. So we have here, so bydict, and then Okay. Excuse me. So we've added here dot underscore underscore rep, and this one it prints it out. So we wanted to do. Did I run the cell yet? Yes. Okay. So vocab. Print vocab. No. Right. I think we'll get to. But yeah, what do we have here? This one. It brings us the representation of it, and we'll get to that in a second. Then we have the init, a vdic get item. So this one is if it's not in the key dictionary. So we're going to try if it's in a key dictionary, then bring it that. And if it's going to get key error, then it's going to look it up from the value dictionary. And here's also we can set items, override them. So here's our new vocab. So ni is you. So here we're calling the same thing, or like the same element, but depending on the keyword value, and this one still works. But then if we call, and here we're setting a new item, so we're adding it in the vocab. So ni hao, hello, ni, and then wu ai. And this one, if we don't have this, oh yeah, it does work here. What did I do again? I like it. It's like so automatic that I forget how to do this. Yeah, okay. If you do a command and then the slash, you can do like multiple lines. That also works in Visual Studio Code, and I want to say in IntelliJ. And command, don't know what's that on the top of my head on Windows. The one that's right next to space, but that's how you do this. So we're gonna get rid of that one. And then, no, it still works. Is that not the one I'm thinking of? Oh, no, we have to do this again, right? Yeah. So if we don't have this, then I think this stands for like representation or whatever. So in order to print it out, we need this method in here. Otherwise, we're going to get this. It's just going to say like, oh, this is a type of bytect at this memory address. So this is how you'll be able to like print out dictionaries if it's a custom dictionary type of object or any type of other object. Again, yeah, so we looked at this earlier. And now we should be able to do this for the bytect. Oh no, we can't. Yes, oh no, vocab. Yeah, so we're passing in vocab, and there's some things that it's like inherited from just being a class. But then we say here's our get, kdict, vdict. Operator overloading. So here's what's happening here is we have a dictionary and then we have another dictionary. With this pipe, you can combine those two dictionaries. So, and it's also going to like, because in dictionaries, you cannot have duplicate keys. So this second dictionary is going to override because we say key one and then key one here. So it actually overrides key one with hey. So dictionaries, unique keys. So if you're combining two dictionaries and there's the same key, this latter one is going to, it's going to override this one. So here, get item, set item, or, and then yeah, what this is doing is, again, we're creating a bytect of this, and then we're combining it with another bytect, and we have this one that's going to do that for us. Any questions? Everybody good? Okay. So that's on the Python basics. And we'll see a lot of this later on. One thing that I wanted to show you guys, in one of these, which one was it? I'm gonna say maybe like, anyways, we had a variable and then we assigned a different variable to that variable. However, when we printed out like the variable, or like we changed something in the original variable and then we printed out the new variable, it did the same thing. Like it wasn't a copy of it. I think that was in the collections, right? In the dictionary. If I can find this example, list of songs. I should clear out, put something here. They're not here. I want to say it was this one somewhere here. One Hit Wonders. Yeah, right here. So we had our list of songs here, and then we did One Hit Wonders equals list of songs. So these are equal right now. I'm gonna print out a list of songs. Then we added Alice, or we overrode Alice's mom, Stacy's mom with Alice's mom here. Print out a list of songs. We have Alice's mom. But then when we print out One Hit Wonders, this one's also Alice's mom, even though we didn't do anything to that. So the reason to that is it's not actually like setting it to that variable. It is just referencing the memory address in the computer. So here we have my array equals array of these things. Then we're going to set my view to my array. So instead of this one like being set to this actual like object of this, it's just going to point to the same location where this variable locates. And that's why when you change something in my array, this one's still going to be pointing to that. So in order to like avoid that, we need to create a copy. So my array.copy, and that one's actually going to copy over this variable to this one. And it's going to point it to its own. Hopefully you can, let me zoom in. Can you guys read this? It's not really helping because it's not zooming in on these. Does that make sense? Any questions on that? All good. But yeah, wanted to show you guys that. And this one, yep. And then we'll go back in here. So I'm gonna do a little bit of review of like overview of what a BI analyst role, or oftentimes like data scientists. And we touched a little bit on like, you know, data cleaning, preparations, analysis. So first task, collect the data where it's given to you, prepare it, clean it, transform it so it can be properly used for analysis. Then we analyze it, visualize it, create reports off the visualizations, and then it's continuously improved. And this is probably what you guys saw in Tableau class. Not sure if you guys did much data preparation. You might have been provided with like already nice looking data, but you analyzed it, visualized it, created dashboards. Then talk about setup a little bit. So Python environment. Python is something that you need to install on computer. If you're using like Anaconda Cloud, that's obviously already in there. But if you want a local Python environment, you would have to install that. Using an integrated development environment such as Visual Studio Code, PyCharm. Those are like the two most popular for Python code. Visual Studio Code is definitely my pick. It's a good one. Or you can use Jupyter Notebooks. Data storage, different types of databases, relational databases, MySQL. You guys took a SQL class. Then there's MongoDB, Cassandra, different types of places like data lakes, cloud storage. We have Amazon S3, Google Cloud Storage, and then the dreaded storing your data in an Excel. Well, database. Data is okay in an Excel, but big databases, no. Data processing. So we'll touch on the pandas today. So Python libraries, pandas or DAS to perform data processing, cleaning, filtering, data forming, merging, visualization. And there's matplotlib, seaborn, plotly to create visualizations. We saw one in the yesterday or on Monday. Some that were created with matplotlib and plotly. Then there's also Tableau, you guys are familiar with, and then Power BI, if you want to create like dashboards. Collaboration, we talked about GitHub, then there's Jupyter Hub. GitHub is the most common one in my experience. I've never really come across anybody using these things. Wonder if you go to, probably if you work at Google, you'll probably use the Google Collaboratory, I'm guessing. And then deploying Python scripts. You can use, like, if you want a Python script that runs like every hour or every day, you can use AWS Lambda, and then Google Cloud Functions. And there's Docker for package and deployment code. Probably nothing that we'll be getting into. RD and troubleshooting, we talked about Stack Overflow, GitHub, PyPy, Jupyter Notebook Gallery, and of course ChatGPT. And then for each library, there's documentation. So if you're not sure like what the methods are available or what they do, you can go look it up, like look at the math library for Python or look up the Plotly. And here's a little example of different things that we can do with the data collection and prep. So here's the data set, PhD, some data on doctorate degrees. So this is how we would import pandas. So pandas is a very popular way to handle data in Python. So import pandas as PD. We saw that with the imports on Monday. So data frame equals pd.read CSV. So this is how we're going to load this CSV file into a data frame. And we'll also see, I'll show you more examples in the notebooks. If we wanted to see like what's the size, the shape and the size, so df.shape is going to tell us that we have 3,370 rows, and then there's 6 columns in this specific data set. To preview it, you can do head.head. You can also pass in a value in here if you wanted to see like the first 10 rows, but the default is the first 5. So here we can see 1, 2, 3, 4, 5, 6. Those are the 6 columns that we have. Then check the data types. We can do df.datatypes. So unnamed is an integer. Integer is 64. Broad field is an object. Major field is an object. Field is an object. Year is an integer. And then underscore PhDs is float. Then we can check like any missing values. PD is null. So here's pandas dot is null. Include passing in the data frame. And here we can also see, is it showing this one? No, yeah. So here it can show like a little bit what's happening here. So here we have false is 91.8%, true 8.3. And so here we're calling help as we saw earlier. So if you don't know like what the function does, so pandas.isNull help function on is null in module pandas is null object passing an object detect missing values for an array like object. This function takes a scalar or array like object and indicates whether values are missing. So this is an NaN in numeric, the non or nan in object arrays, and then NAT is for date time. And then it tells you more about these things. You can check for duplicates, df.duplicated, and it's going to tell you that there is no duplicates, 0 duplicates. Check for outliers. So looking for the statistics of them, mean, median, standard deviation, check for any outliers. So describing our data set, we can see here. So And so this one I think only works for integer, so numbers, integers or floats. So count, we have this many there. So this one has some empties. Mean of these values, standard deviation, minimum, the 25th percentile, 50th percentile max. So that's kind of, you can like have a quick overlook of your data values. Okay, so getting into data cleaning. We're gonna go to, so if you, I think I did put it in the chat. Let me shut down all of these, close all of these. Oops, stop. Okay, so if you don't have these already loaded, this is where we're gonna go. We're gonna go Anaconda Learning. So when you first open up anaconda.cloud, just remember Anaconda Cloud, and then hit Notebooks, make sure you're signed in. You're gonna come here, then Anaconda Learning, then data preparation, and then cleaning and preparing data with pandas. And this is where the notebooks are going to be. I can put that, let's see, I'll put this one in the chat. Okay, so data preparation and cleaning. Preparing, and start this. Okay, so pandas basics. Pandas, you're going to be using it a lot. Very popular. Derived from the term panel data, also popular. It's a popular Python library for preprocessing and analyzing data, particularly in tabular format. It's really nice. It helps, like, it visualizes your data really nicely. Just easier to handle it. Like, it kind of shows it as a spreadsheet. So setting up pandas, this one in the Anaconda Cloud, it's going to be installed already. But if you were to do this on your local machine, if you're using Anaconda, you can do conda install, or then if you're just doing standard Python distribution, you can do pip install pandas. And that's what you would do in your terminal. So I have both installed here. So can I zoom in on this one? Yeah. So we can do pip install pandas. And this one's going to tell me that requirement already satisfied. And I can also do conda install pandas because I have both distributions on my, no, do I not have it on here? So yeah, here, conda install pandas. No, actually, I think he's doing something else for here. Anyways, that's how you do it. But you don't have to do that because we're going to be using Anaconda Cloud. And then at the top, we're going to do import pandas. Actually, let me do, hold on. Restart this one. Yeah, so import pandas. And then there's also NumPy. So NumPy as NP and pandas as PD. These are like very widely accepted renames of these libraries. So series, so we have series and then data frame. So series holds a single dimension of data. Think of it as a single column, similar to a plain list in Python. So here, so we have these values. We're going to name it as temperatures, and this is the type. So when we print it out, we get these, and this is the index. But it's not part of the values. The index is not. Yeah, so index, and we can access it by index. In order to access something by its index, it needs to have the index there, obviously. But you can also assign, a different index to in pandas, in the data frames, and we'll see that in a little bit. But yeah, so index 3, we're going to get 98.1. So series, PD series, this is multiple. So our index, so here we're overwriting the index. So instead of using standard 0, 0, 1, 2, 3, whatnot, we're going to use Monday, Tuesday, Wednesday, Thursday, Friday. then this is going to be the data, and this is the name of the series. And here again, we can see like earlier when we looked at, so this again, we're doing pd.series. We only have 2 arguments in here. So we have our data and then we have our name. But here we're calling pd.series, but we have index, data, and name. So the index has a default value of just 0, 2, 0, and so on. So now we can access this with, this is the overwritten index. So you can access by that. Any questions? And then data frames. I think data frames are like more common. At least I've dealt with data frames more. So data frame, basically thinking of just like a spreadsheet. So here we have data, and this is going to be the, so column names, company name, address, city, state, zip, category, number of employees, and these are inserted as a row. So each row, so columns, company name, address, city, state, then we inserted here auto antiques, 5732, blah, 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 commercial industrial. And that's how you can, that's how you create a data frame from like scratch, but you can also get it from a CSV file, Excel file, and we'll see that in a little bit. So DF shape, 3 rows, 7 columns. 1, 2, 3, 4, 5, 6, 7, and then we have 3. And this is the axis 1 and axis 0. And then if we wanted to just look at the addresses, we can do df address, and it's going to print out just the address column for us. And then we can select multiple company. So this one is, yeah, so get only these 2 columns from this data frame. Oh, here's another data frame with some contact information. We can get the columns by df.columns. It's going to tell us what they are. And then index. So here it takes our range index, starts at 0, stops at 3, steps 1. So that's like the standard, the default value for it. I think we talk about this location at some point. So yeah. So to receive index by row, we can do .lock. So this one, it gets us row 3. Let's see. First name, yeah. So this is different. So this one, we didn't set the columns, so this is how it was set. So first name, these are the values. So these were inserted by column instead of inserted by row. So here, location 2, it's gonna get Joe Morris. So 0, 1, 2. So it's gonna get us the last row. Joe Morrison, Joe at rexandmetals.com. Then we can set the index in place true, which means like it just does it for the original one. And now you can like look them up. So instead of index being this, I think if we print this one out now, let's see, df. So now our index has been overwritten by email. So you no longer can look them up by like this location 2. Now you have to look them up by the email, but that's how you can override it. And then now it's, if we look at the index again, these are all the possible, type is object, and then the name of the index is email. And then if we did that on accident, we can reset it. And now we have our regular numerical index back. Any questions? So importing data, this is the fun stuff. So there's multiple different ways to import data into Python to be prepared, whatnot. So this one, So urlib request, this one takes in a URL and then retrieves whatever is there. So this one downloads a CSV. We see maintenance underscore predict CSV, and we want the raw format of it, and we want it to be maintenance. So that one, since I've already run it, it's going to be here. But if you run it, it's going to download it over here. And then the second one is downloading SQLite database. And the last one is going to do a JSON file. Then and you can see 3 seconds ago, so it basically overwrote all of these. So reading a CSV, read text file path with open file path as F. So open this file as we rename it to F, and then return read lines. So read text, passing in the maintenance CSV to read text, and this is going to spit out all the rows to in the CSV. And then this is usually what you want to do is we want to create a pandas data frame off of it. So pd.read, and now we're going to get a much more pleasant thing to look at. Then there's reading the SQL database. So our DB here, import SQLite. We're going to make a connection, connect to this database. And if you don't have the database locally, it's somewhere in the cloud. This one would take into like authentication, password, username, things like that. So here, so you guys are familiar with SQL, select all from customer, read SQL. So we get this. And then reading a JSON file is the same thing. We're using the read text. It's just going to spit out the raw JSON here. But we can also do it with PD, read JSON. And again, it gets loaded. Well, it's not loaded into a data frame. It just, since we're not setting it, but yeah. So here, let's see, data frame out of complete the code, data frame. Oh, yeah, complete this one. Yeah, so we wanted to do an actual DF. So this is how you can create anyone. And something to be mindful of is like, not greatest practice. We're using DF. That you don't have to name it DF. It's just like, I don't know, such a normalized thing. But basically, every time we do DF equals, it is overriding the last time we did DF. So something to be mindful of, because again, like if we did this and then we went back somewhere up here, it will be using this data frame. It wouldn't be using whatever was above there. So be mindful of that one. Any questions on pandas basics? Different ways to read data. Okay. Selecting rows and columns. Okay. So again, we're creating a new data frame here. This one, yeah. Okay. Okay, here. So there's the dot loc, LOC, and then there's dot iloc. So the difference between these two, it can be a little confusing because it may seem like they do the same thing. So if we do df.iloc and the df.loc at 0, it prints out the exact same thing. But the reason they do behave any differently is because the index is just the default index. But what the actual difference here is the location gets it by labels, and then the iloc gets by indices. So iloc, we want the index 0, but then here we're getting it by label, like the index label, but it says the indexes are just 0, 1, 2, t, 1, 2, it's gonna do this. So here, if we do set index to username, so we're overriding it. Well, let's look at this one real quickly. So now again, we have username instead of having this index here. So we want to use the username as the index. So now when we do ilock 0, this still works. But when we do .lock 0, it's not going to be happy. It's going to be like, oh, doesn't exist. Type error. But now we can do it by Thomas Nield. So that is now the username. So that's what the lock is for. You, whatever the index is, you'll use this for. Any questions on that? Okay, selecting ranges. So looking at multiple rows, multiple indices, we can do df.ilock from 0 to 2. And if you recall, this one's inclusive, this one's exclusive. And a good way to remember this is that kind of like parking spaces and these lines. So this line is 0, this is 1, and this is 2. So we want from 0 to 2. So it's only going to get these 2 elements right here. Instead of thinking it from like the indexes, which technically it is the indexes, but this would be 0, 1, and 2. But yeah, if you look at it this way, so we're looking at what's between, selecting the indices between each digit. If you want from starting from 0, you don't have to write it. It's going to give you the same thing. So this is same, putting 0 here or not putting there. If you don't want to do, if you don't care, like if you just want end of the things, so from 1 forward, we're omitting the 0 index. And then if we do, this one's going to select everything. Provide second range against certain columns or specifying include all rows. So this one, we're only grabbing. So this one grabs all rows, but we only want columns 1 to 3. So 0, no, actually 0, 1, 2, no, 0, 1, 2, 3. So 1, 2, and again, 3 is exclusive. The reason we have the username still here is because that's the index. So that's technically not part of the data frame anymore. Like it's its own thing. Also can use negative indexes. So from starting from the opposite direction. Same thing as we were looking at dictionaries or selecting anything there. Picking rows and columns. Could provide a list of indices instead of a range to pick only certain columns. So here we're picking rows from 1 to 3, exclusive 3, and then we're only picking 0 and 2. So index, let's see, where is it? 0, 1, 2, 0, 1, 2. So first name. Picking first name and email only. And then here's, instead of doing it with the ilock, we can do it with the lock as well. Again, we're setting index as we saw earlier. So now it's back to 0, 1, 2. Any questions on that? And this is something that like you can memorize, but again, quick Google search too, if you don't remember how to exactly do it. I promise everybody still uses Google. You just need to know how to do things honestly, but you're not gonna remember like everything. Like Python syntax is so much. So some things you'll still have to look at. Dropping rows by condition. So I feel like dropping here is a little misleading, but like basically filtering. So from column username, it's a string, starts with S. So we only want to see which ones. So 0, let's see, where do we have? It starts with S. So username does not start with S, does start with S, does not start with S. So it's giving false, true, false. And yeah, you might have expected that it would just spit out the thing, but we're just getting the Boolean for right now. So here we would do condition equals this, and then we're going to get the condition and that way. So this one basically would have to be, if we embed it in here, does that work? No, df in here again. Yeah, so this thing is same thing as this. So condition equals df username. So putting condition in here, same thing as doing this here. And that's how you actually get the result out here, which is right here. Yeah, it's good. Ahead of myself. We can use the and or operators to do things. So df, so this is going to be the full condition here. So username starts with S and email contains Gmail. We're going to get the same one as here. Then, so this is where you're actually dropping rows and columns. So like you decide that certain column, you don't want to consider it anymore. It's not important. This is how you can actually, or row or whatnot. So if you wanted to, so this one we could do like df equals df.drop, and that one would overwrite the original data frame, or then if you use in place, it would do it to it. But here we can see that if we do df, it's still here. But if we did it in, well, I'm not going to do it because it'll mess up later on. But yeah, set index to username and then drop this. So here we're setting the index and then dropping these two, which means we only get this one left. And also use drop to remove columns. So we got rid of username and email, and now we only have first name and last name. But again, this is not overwriting the original data frame. Appending rows and columns. So this is basically like this. You can like, this is how you can add a new column. So you just put like, hey, df, I want to create a new column called phone. And this is going to be all the values that's going to go in there. So you're like inserting the column in it. It's like not the most intuitive way to do it. And it's also kind of confusing because you would think that because we don't already have a phone column in there, this wouldn't work. But yeah, that's just how you add it in there. So now we have phone in here. Then we can also insert if you want to like want it a different like specific location. You don't want it to be added at the end. We can use the insert. So here we're inserting at index 3. The column name is going to be Twitter, and then here's the values for it. So now we can see that Twitter got added in here, and this was 0, 1, 2, 3. So it got added at index 3. Same thing with the log property. So location 3 is a Marley. So this is adding row in here at row 3, which, yeah. Also use concat. So yeah, multiple ways to do same thing. Then if we want to update data, so let's just say like all the emails, we actually want all of them to be uppercase. We can do df email equals df email string upper. So this is basically like if you name this something else, it would just add it in here, but this one it just updates it, and this one's like the values of it. So now it's all uppercase. You can also update it on a condition. So if the first name equals to Joe, then we're going to add the Joe at gmail.com. So location based on condition, set email to this if it equals to Joe. So here, joe@gmail.com, what got updated to. Now updating a row using the index. So this one's just updating the whole thing. So Sammy and Scala, none. Updated. Then melting, I feel like this is a strange term for this, but situations where you want to unpivot columns to become row values. So here we have a data frame, categories, alpha, beta, gamma. We have 22. So here, like, so the revenue amount is by category, but also by the years 2022 and 2021 as two separate columns. So that's not a great way to like represent it. So what we can do is, yeah, so melt, give the ID category, value wars from the two 2022, 2021 here, and then amount. So now we're, instead of having 2022 and 2021 as the columns, we have it as a row value. So that's something you can wrangle it that way. Any questions? Okay, and then there's an exit at the end. You guys can do that on your own time. Sorting, casting, categories. Okay, again, starting with the data frame. So we have some wind speeds here, data types, passing. So there's DF types, integer, datetime, bool, time delta. So yeah, and then we can also view them this way. As we saw earlier, we did like df.d types. Just gonna tell you what each one of these is. Actually. Yep. And so talked about previously, like when we have a string that's a number, we want to like cast it to an integer and whether or not it's going to work if it's a proper one. So tornado, df tornado as type bool. So tornado right now, it's a integer, but we want it actually to be a Boolean. And same thing for lightning. So these are zeros or ones, so true or false. So we can cast them as Boolean. And zeros and ones can't be casted into Booleans. If you had a 2 here, that one would break. So now, instead of having 0 and 1, we have true and false in here. And then if we look at this again, we're going to have tornado is bool and lightning is bool. Then sorting values. We can sort by lightning and then rain inches. So we have our lightning here and then rain inches. So these two, we want to sort it. So first it's going to sort it by lightning, and then it's going to sort it by rain inches. Yeah. So these are all from, so ascending. So false first. And then these ones get sorted afterwards. And then I think this one is, yeah, ascending. So if it's, I think this one it considers alphabetically. So F comes before T, but you can also, because obviously numbers, it knows which one's like ascending or descending, but you can also tell it what's the proper way to treat it as ascending or descending. So now it's going from true, false. And again, a reminder here, if you're not using in place true, it's not going to be doing it to it. So if we were to if we look at DF right now, it's not going to be sorted that way. We can also sort it on an index. So we're setting the record ID to be index in place. So we can sort it based on that. And now it's going to be alphabetically sorted. And sort, yeah. So you could also have added it as a column. Categories. So then there's like times when kind of like data validation in Excel. If you shared a spreadsheet with people and like you want them to only select certain values, like you say like, oh, what days are you going to be available? You don't want somebody to say like January. You want them to say Monday, Tuesday, Wednesday, whatnot. So you can also do that here. So categorical D type. So here cat type, these are the only like values that we want for it. The category is clear, minor, major, severe, order true. So these are only the acceptable values that we'll take for the severity. Yeah. So here, severity, as type, cat type. And here we'll see, run this first. So severity clear, severity minor, major. And then when we look at this, we see that severity is a category now. We didn't, no, we did have it here, but beforehand, did we look at it here? Yeah, severity was an object. So you can set them to your own things. And then we can sort values by severity, here, minor, major. And that one, so here like ordered, so that kind of like determined what the proper sorting is for that one. Clear, minor, major, severe. Then we can use apply. So we have our function map wind speed takes in an argument x. If x is greater than 60, it's gonna be dangerous, above 30, high, 15, moderate, low. So it's gonna look at the wind speed miles per hour and applying to that column this function. And then it's going to say, okay, this record, the wind speed is low, this record is dangerous, and we can add it. Here we're adding it as a new column. So here we can see, okay, so wind speed 3.1, low, 143, dangerous, 12.2, low, 19, moderate. Any questions on that? And then, okay, removing duplicates. Yeah, so, okay, let's see, the same thing. So we obviously we want to get rid of duplicates. We don't want null values. We want our data to be usable. And this one, we can, to get all the duplicates, but the first instance of a row, use a duplicative function. This one again. I meant to do this, but I forgot to do it on these ones. So duplicated, you can flag all the instances by setting keep false. And then we can also look at based on just a using only a singular column. So looking at record ID, if we have any duplicates in there, or then we can look record ID and ranges. df.drop duplicates. So this one actually gets rid of the duplicates. So that's all the rows that are like exactly the same. So like every single value is the same. And using the in place, it does it to the original data frame. And here, again, you can based on a subset. Removing columns with one value. You can do n unique to identify the number of unique values. So this one tells you record ID, so they're all unique. We have 6 records, they're all unique. Ranges, we have 5 unique values, but transmit ID, we only have 1 unique value. We can see they're all the same. So if we didn't want to, here we're doing, so delete columns, column value in zip, df.columns, and unique. If value equals 1, we're going to. So this one gets us which column we want to drop. And then df.drop, delete calls, axis 1 in place true. And now we got rid of transmit ID. Then we can remove columns with few values. So like if we're only, weather data, we only expect true or false for Boolean fields. We only expect for possible values in the weather severity. So let's look at a different data set. We have wine quality data set. And this one has 1,599 rows, 12 columns. And so here we get rows and columns. So for each row, for each column, I in columns, unique number, check the number of unique values in that column, then the percentage, and then print out. So column 1, this is the number of unique values, and then the percentage is what percentage of all the unique values compared to the whole set. And then this one is based on, so again, we get the unique number percentage. If percentage is less than 5, we want to delete those columns. So these are the columns that we want to get rid of. 1df drop delete columns. So here we could see now, so we had 12 columns originally. So if we were to look at right now, 1df shape. Now we only have 9 because we dropped those 3. Any questions? And another way, remove columns with low variance. So if you forget statistics class, this looks familiar. If you forgot about it, that's completely fine because I've forgotten a lot of those things. So a library that we're going to be using later on, sklearn, is a pretty big statistics library. So this one is we're importing variance threshold from here, setting it to 0.05. Higher the parameter, the more columns it will eliminate due to higher cutoffs. So x equals get the rows based on index. So this one gets all of them, and then everything to tell the last one. Threshold. It just gives it an array. Features before, number of features after. So based on the variance threshold, we've gone from 11 to 5. And this is just a way, you don't have to understand every single thing about this one. It's just a way you can remove columns based on them. Once you get into hit rate data science or analytics, you might use this. Any questions? Okay, we'll do, let's see, we're not going to do that one. 2, 3, 4. Okay, we'll take we'll take a quick 5-minute break, and then we'll continue on this one. We'll be back by 8:25 p.m. Okay. Yeah, this last notebook is just, I think it's just like all of it together. So we just have these for to get through. Yeah. Missing values, we don't want that. It's going to cause problems. So again, so here connecting a different SQL data. Is this the same one? Yeah, this is the same one. Yeah. So again, downloading the same SQL database that we downloaded earlier, connecting to it, and then we'll get everything from weather monitor, where location ID is this. This is what we're going to be looking at. So to find missing values, we can use the is and a, and this one is going to show us if it's missing or not. And then any to see if the columns are. So we can see that there's some missing values in temperature and then rain. And this is obviously going to be a problem if, for example, like want to look at the average temperatures and we have some missing values, then it might not be accurate. Flipping the axis, whether each row. So here it looks at for every single row. So here is missing values. Here's missing values. And we also have not NA, which is just the opposite of that. So here we're gonna pass it the dot block getter to retrieve those values with the null values. So here we can see null or NaN, 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 NaN. And if we wanted to find like the missing values for specific columns, use the filtering operation. So we'll check any values in the temperature column or in the rain column, since we're already determined that those two have missing values. These are the rows. This is how we get the rows to it. So rain, these three have missing values, and then this one in the temperature. A different way to do it is just doing this. So this one, instead of just looking at these two columns, we're just looking at based on the rows, and we'll get the same thing. So similar to before, where we were removing duplicates or dropping columns, we can drop rows or values. So drop NA, axis 0, and again use in place true to replace the current data frame. So this one, let's see what were they. So yeah, so we can see that those were removed from here. We no longer have those 4 in here, but again, we did not replace the original data frame. And then here, if we only want to look at this rain instead of rain and temperature, or all of them. So this one was looking at all columns. So this one's just filtering it based on the rain column. So the one value that did have, so temperature, so 466 here. So 466 is still in here because we were not looking at based on temperatures. Then the most common practice is to just replace the missing values instead of like getting rid of them. And that one can also help later on to like filter, like, oh, only look at the positive values instead of just like getting rid of the empty values. So here we can see that this one is replaced with -1, and then here's -1. So that's what we replaced it with. So fill NA with value, and again in place. So this one replaced the actual one. And you could do different things, 0, whatever, it makes sense. And there's some other, again, there's multiple ways to do the same thing. So if you look at the pandas recommendation, there's other ways to do that as well. Here is, if we want to replace certain values with NA, such as empty strings, replace folders like null, we just turned NA values into -1. So this one's converting them back to. So again, here's the replace. We've seen this one before. So replacing all the -1s to NaN. So here we can see NaN back here. One way to handle missing values is to replace them with mean. This is where the sklearn library comes in handy again, because it has a different statistic thing. So replacing with the mean or median. So we can apply this to temperature and rain. So our imputer, simple imputer strategy equals mean, transforming input. So this is looking at only these two columns, and then imputer fit. And then it tells us the means over here. And then here we can create a copy. So remember how we went over the variables and pointers. So creating a copy of it, and then we're going to transform the output with this imputer so transform with the transferred input. And then now, if we look at, so we had 466 for temperature. 466. So now it's been replaced with the mean of all the values instead of replacing it with -1 or 0. And then I think, was this one maybe? Yeah, the rain. I think both of these were replaced by the mean for the rain. And there's different ones. We can use mean, median, most frequent, constant. Any questions on that? Another way to fill them with the nearest neighbor. So imputing a value to replace missing to leverage the k nearest neighbor, KNN. So again, sklearn. So here we're going to look at the KNN imputer and use the 5 nearest neighbors. We will make the weights uniform and tell it to ignore the empty values by setting your metric to non-Euclidean. I'm not sure how to pronounce that honestly. So yep, created our imputer again. And then we're going to copy the data frame and drop the 2 columns that are not useful for modeling. So we're going to get rid of the ID, report code, location. So this one we're creating, so this is the copy of the data frame. Setting to this, extract the day of the month and make that the report date. So report date equals report date, and then string format as the day of the month, and set it as an integer. And then here, so report date, instead of it being, so here's our report date. So we're just looking at the month. We don't care about the rest of it because it's all for the same month and year. And then we dropped ID, report code, location ID. And this is what we currently have. And we'll copy one more time and then transform the temperature and rain columns. So copy it. We're going to apply the imputer.transform on KNN input. And then apply it to only the temperature and rain columns. So can output dot lock all rows, only these two columns equals the can transform all rows and then only these two columns. And that's how we'll then get temperature. So now we have 55.76 here. So based on the 5 nearest neighbors, this is the value that we should be filling in for this one. Any questions? An exercise for you guys to try later. And talk about outliers. So going on into from statistics class again. So here we are looking at golden retriever weights. So standard deviation outliers, remember from 1 standard deviation, 2 standard deviations, and 3 standard deviations. Well, this is what we're going to be using. So mean, DF mean axis 0, get the first one. So this is how we're calculating the mean and the standard deviation. Mean is 64.4, standard deviation is 3.026. And quick refresher for if you don't remember what standard deviations is. So 1 standard deviation means that 68% of the expected data points, assuming the norm. So mean will be, so assuming a normal distribution. 1 standard deviation is 68%, 2 standard deviations will capture 95, and 3 standard deviations will capture 99.7. So inspect the outliers. So here we can do, so we get the lower bound based on 2 standard deviations, upper bound based on the mean plus 2 standard deviations. So outlier condition, if the weight is less than lower or upper is less than the weight, which this could also be written, I think it would be better to represent it as DF weight is greater than upper, but works either way. So this is where we get only these two are within the 2 standard deviations. So this, so these are outside of the 2 standard deviations. Yeah. So we wanted to remove them. We would apply it in here. And we'll get our outliers. So now this data set, we got rid of these two because they're outside of the 2 standard deviations. So that's a good way to get rid of outliers. Interquartile range outliers. So yeah, looking at percentiles from the NumPy library, we can do percentile. So the 25th percentile, 75th percentile. So passing in the DF into the percentile function, getting the 25th percentile. And then we can calculate the difference between the 75th and 25th percentile to get the IQR, the interquartile range. Any questions? Okay, so we want to use k equals 1.5 and calculate cutoffs. So k equals 1.5, cutoff, IQR times k, lower minus cutoff. So the 25th percentile That's cutoff, upper 20, the 75th percentile cutoff, and that's how we get our upper and lower limits, and then we can remove all the outliers that are outside of this range, which is harder to see on this. The bigger data set. And this one saying that the k-value might be too generous for this data set if we're looking to remove outliers. So we can adjust it. So if I adjust it to 1.1, removes an outlier with an index of 11 and weight 59. So again, we could look at the shape here actually. Well, so this one, we get 49, index 49, 49. Does it do it? Oh, no, yeah, it's removed different ones. Yeah. But yeah, that's kind of like something that as an analyst, data scientist, you have to kind of figure out what the proper values are for your data set. And then this is the last one. Yeah, so using local outlier factor. So if they're too far away from the rest of the data points in a multidimensional space, they can be detected as outliers. Sometimes might be less reliable in higher dimensional problems due to curse of dimensionality. So again, from sklearn, local outlier factor, and we're using the maintenance predict CSV file for this one. And we'll create a local outlier factor with the default settings. So LOF equals just the default of this, no arguments passed in. Outlier LOF dot fit predict. We're going to pass in df, all rows, and then all the columns except from beginning to except the last one. Yeah. And this is what we get right now, because we get a -1 for every record that is deemed an outlier, and that's because we did it. Because we did it with the default settings. So if we pass in this series of booleans back to the data frame, we can omit those. Oh, sorry, no, this is. Oh, sorry, I looked at that wrong. Yeah, so -1 for every one. So here's a couple of them. Sorry. So you can see which ones we want to. So if we pass this in here, so our outlier index is not equal to -1, then it's going to get rid of those -1s from here. And again, if we did a in place true, it would do the actual original data frame. Any questions? And this is definitely something that you can refer to the docs on how to do exactly. Like first you'll have to determine like what's the best way to get rid of outliers, but then you'll have access to the documents on how to do them. And you can always do that help function also in, as we saw earlier. Okay, any questions? Okay, dates and times. This is a pretty short one, and I think the last one is a short one, so we should be able to get through this. Okay, dates and times. Could be tricky because things don't always get handled properly. They're not formatted properly. You have to take into time zones. So we'll take a look. So data frame, we have date time formatting CVS. So here we have different kinds of things. Let me scroll over. So we have seeing it in different ways. Kind of like when Excel, you can select what format to put your date and time. So we have the short date, long date, whatnot. So let's look at is it the last one? We'll look at this one. Order date time TM1. So we have the date and the time in here. And then if we're looking at it, so this one shows that it's an object. Every single one of this is an object instead of being like an actual date time. And we want it to be date time if like want to filter things, compare dates to each other. So here I'm going to parse it. So pd.toDate time df, and then we're going to pass in this one. And okay, parse individually. Yeah, this one's, it's fine. It just, so here's the warning that we were looking at warnings earlier. But yeah, so now it's converted to date and time. And all of these are like, this is the date and time format that, like the default one. And then now we can look, so parse column. So this is the column that we're looking at. And then .dt and the day of week. So now that it's a date time, we can access the extra properties. Day of the week. So 0. So January 22nd in 2022, that was I think this is Friday. If it starts from Monday. And then we can do when we're reading it in, like when you're loading the data, passing in the URL, and you can already like parse the dates when you load it instead of like loading it first and then parsing. And again, it's going to give this warning. So now they're all in the same format, or these ones have a time, but both of these dates compared to what we had before, we had all these different. So this one was with the slashes, this one was the last slashes, and these are like the long date with 12 hour clock on Tuesday, April, with the day of the week and everything. Actually, here we can see the, oh, Saturday, okay. Right, so starting from 0, that's right. See, don't forget about the index. So yeah, so this you can parse it. Parse dates parameter. Any questions on this? So yeah, here's we already looked at the original values, yep. And then, so when you want to like decide what the format will be instead of like using the default, you can use these two, the string f time and then string p time. Oops. And these are how you determine them. So if you wanted to use a two-digit year, you would use the percentage sign y, and that's why, yeah. So here we want to parse, so order date TM2. So order date TM2 we have right now is 22-Jan/22, and then the time. So if you like wanted to, if it's like an uncommon format, then this is how you determine that. This is how you tell Python like what it needs to do in order to convert it to a date time. So this one's following what we had up there. Let me add it here real quickly, the df head. So we have the date. No, this is the year, which is confusing. Yeah, so year, month, day, and then here. So year, month, day, hour, minute, and then AM, PM. So like if it was like in a really wonky format for some reason, which will probably happen one day because you don't get the best data always. So you'll have to tell it to like how to properly parse it if it cannot recognize it itself. So now I was able to. So daytime right here. So it got parsed. Yeah, so now we have all our dates working, and then we can do analysis on it. So np.sum df parsed location all rows, looking at order date time, tm1, tm2, tm3, checking unique values equals 1. So all 1,190 rows have exactly one unique date time value in each row. And then we can do the same verification this way for, well, no, for these two columns. And they were parsed correctly. Then, so here, filter in date times, and that's why it's important to convert it into an actual date time instead of just being in an object or a string. So df equals df parsed. We're getting these columns. Then we want to rename these columns. So order date, order date, order date 1, order date tm, order date tm. Columns suggest, yeah. So this is the new columns. So these were the columns we passed in, and these are the renamed. Yep. And then so condition df order date day of the week equals 1. So wanted to get all the records where the day of the week is Tuesday. So in the dt.day of the week property, 0 is going to be Monday and 7 is going to be Sunday. So Tuesday is going to be 1. That's why we're checking that it equals 1. So this is going to get us only the values that the day of the week is Tuesday. And you can't really see it based on this one because it's not there anymore. But so 170 rows are Tuesdays based on the order date, this one. Yeah. And then we can also quickly filter dates. So here's like, before, after, greater than equal operator. So order date is after June 1st, 2022. So we have 695 rows that are after that. And then, yeah, here's different ways to do it. Well, yeah. And here's the format, yeah. It's just different ways to do that. We'll go over the time zones and then I think we'll be able to get the wrangling data super quickly. So when dealing with time zones, there is a library called PyTZ. And so this one, common time zones, prints out all the common time zones that we have. So you can basically set it like, okay, we have a time zone. So for PyTZ, time zone, use Arizona. So now we can use this variable as this, so we don't have to rewrite it every time. So if order date tm date tz, so tz is none, print tz naive, otherwise print it. And yeah. So we have no information about the time zone, so that's why we're printing it naive. But we can do it. So tz underscore localize function specifying where they're recorded. So we'll say it was recorded in Arizona. So now we can see here datetime 64 ns dot comma US Arizona. So all of it is going to be change to this, and then we have the negative subtract 7 hours. So from UTC. And then now we can convert it to use central. So depending on what time of the day it is, it's gonna be yeah. Oh wait, this is yeah, US central. Sometimes 2 hours ahead of Arizona, but also sometimes 1 hour ahead because we don't have Arizona daylight savings. Yeah, so that's why this is Arizona time and this is central time here. And then here is to convert to UTC. Plus 0. Any questions on the time zones? Okay, let me take a look at this one. Really, we'll leave this to, yeah, this is, yeah, we'll spend a little bit of time on here because we'll get into regex that we talked about earlier. So we'll save this for Monday. And that will be it for today. Anybody have any questions? If you guys have any questions, you can like drop it in a chat. Or if you have questions like you're looking at this later, today, tomorrow, whenever, you can just drop it in Slack and we can go over it, or I can respond in Slack. But yeah, any questions? Anybody doing anything fun this weekend? No fun. Okay, let's see. Did I get everybody who was here? I think so. Yeah. Okay. Well, that is for today. No like specific homework. I would go over some of the exercises that are here and see if you can figure them out. They do have the answers at the bottom, but yeah, review these and then go through some of the challenges and the exercises. But I won't collect it or anything, but for your own learning purposes. Have to work this weekend. That's sad. All work, no fun. Okay, no questions. That is all for today, and I will see you guys on Monday. Any questions, drop it in Slack. I'll be checking it periodically. Thanks, everybody.